So now let's continue our road to power, to exploring power, and see what high power can buy you. And let's also have a look at what high power can not offer, where it has definitive weakness compared to a lower power amplifier. But when I mention power, you have to compare apples to apple. If you compare apples to oranges, it won't work. So if you are comparing, let's say, a 20 watt junk cheapo amp to a 1000 watt highest of the high end, then the dynamics there is completely different, and I will talk about that as well. What I am here referring to power is if you take the same amplifier that has the same circuit design, same topology, same part selection, and the exact same power supply, and within that scenario, if you choose to build that amp to have a much higher power output or a much lower power output, what is the difference between the two? So let's say maybe there's you take Dan D'Agostino amp, and it has maybe 1000 watts output power. So how would that same amp behave if you would scale down the output section from a kilowatt to, let's say, 10 watt or maybe 1 watt? Because when you look at the Relentless, I think he uses like 100 or 200 amps within the amp, and he massively parallels them to achieve that tremendous output. So how would that exact same amp sound if he would use only one out of those 100 or hundreds of amps? Would it be better or worse? No, that's where we start. So I'm telling you that for detail level, the lower the power output, the more micro details you get from the amp. So if you are scaling up the wattage, then when you listen to soft volume, when you listen to the finest details, you are getting less and less of that. And why? Shouldn't, like, when you multiply power 1,000 times, shouldn't 1000 be 1,000 times better than 1? That's not how it works. So eventually, to get 1,000 watts instead of 1, it means you have to amplify the signal 1,000 times more compared to getting 1 watt. And by doing that, by taking the amplification 3 orders higher, you are introducing 3 orders higher equipment distortion. And the bonus is that you are getting much higher peak power output, but the problem is that you are getting that much higher distortion. So what are people doing to fight that? We'll have a look at that as well. But now on this side I have something else to say to you. So let's stick with this order, and eventually the true limitations to how much detail level you can get out of your amp are the speakers. So if the speakers have greater sensitivity, greater efficiency, they will be able to resolve more of the information you are throwing at them. So the best low-level resolution you will get from a system that has an amplifier that which has a peak output around 1 watt, maybe a little bit more, and speakers which are over 100 dB efficient. And in this scenario, you are amplifying the signal the minimum that is required. And if you amplify it even more than that, then you are introducing more than the minimal distortion to the signal. So from that point on, you will get more headroom, but your baseline the fine details, they will get slowly dissolved and distorted by the amplification process. And that's because when you scale up power, you also scale up the distortion inherent to your amplifier. And people use feedback to get rid of amplifier distortion. However, feedback is not an intelligent process. It is a general destructive mechanism that erases the smallest detail level in your signal as well. So to make 1000 watts work for you, you have to apply corrective mechanisms that will delete more of the finest details. And when you are amplifying the signal more to get that high power, you need more amplification stages in your amplifier. So it means you are adding 1, 2, or 3 more stages to get that amplification level. So with each stage you are adding the noise of that stage, the distortion of that stage, the parts quality of that stage, and each added stage degrades the sound, takes away from the purity of the signal, and adds its own colorations, own distortions, own omissions. Because in audio, the THD and active distortion that the amp adds to your system is just one part of the distortion. So when we think of distortion, it has two sides. And on one side of the scale, you have this additive distortion that we measure as harmonic distortion. There are other types of additive distortion, not just harmonic, but those are really difficult to measure and they are not measured. So the non-harmonic distortion, so maybe your equipment has super low level of harmonic distortion, but its non-harmonic distortion might be still really high. And that's the case for solid-state amplifiers. We'll have a look at that later on. But anyway, so when you measure added distortion, we have a pretty good idea about that, at least of the harmonic component, how that works. But there's also omission. And if you look online, there's only Herb Reichert who is talking about that distortion. And otherwise, there's a general quietness about it, which is that when you listen to a music, you notice that with some amplifiers, you are not getting the tiny details. And that's the omission. That's when the amplifier is erasing the low-level signals. And when you add more stages, you are doing that. You are smearing the low-level signal. Or what Dan D'Agostino does, massively paralleling output stages, that also adds a smear, because each stage is slightly different. They have slightly different linearity, slightly different amplification, and you can use tricks to normalize them and to bring them closer to each other, but you still get drift between them. You still get inequality, and they're not going to be 100.00% identical, and because of those tiny mismatches, you are going to get signal smear. So if you would just put half down those sections, you will notice that when you listen to that amp, you can hear the finer details better. And so when you generally talking about any amplifier, the more complexity you add, the more parts involved you add, the more potential you have to erase those micro details. Let's see. So eventually, people use feedback to correct a lot of distortions that the amplifier adds to the signal. But feedback doesn't address that part which when the signal gets lost due to the noise of the stage, where the low level signal gets eaten up by the noise floor, feedback cannot do anything about that. And it cannot do anything about when you have multiple parallel stages, and because of the imbalance between each stage, they are eating up the micro details. Feedback doesn't do anything with that. However, in those situations when feedback can be applied, it's still an issue because it erases micro details. It changes, it alters the phase information, and that's because there's always some time lag when the feedback is applied back to the signal. So imagine that there's like a really huge signal, like a big peak coming in, and right after that huge peak you have a tiny blip. And when you apply the negative feedback to correct for the giant peak, it arrives just a tiny, like a microsecond or a tenth of a microsecond later than that huge signal, and it's going to smear that tiny signal that follows this gigantic signal that needs correction. And when they publish figures about feedback, it's always a nice and clear-cut situation because they measure it under really nice controlled pure sine wave, but that's BS because that's not how it works in real life. In real life, the music signal is super complex, and when you are applying feedback to it, you are messing up the phase response of the high frequency content. And when that happens, a lot of micro details are getting erased. And if you do not want to amplify your signal to 100 watt to 1000 watts, you leave it at 1 watt level. You do not have to go through these excessive corrective mechanisms that destroy a lot of your tiny detail level. And for low level details, when we compare tube amps versus solid state amps, the amplification range, the linearity of the device that defines you what is the working range of your technology, of your amplification device. And if the working range is greater, it means that it can amplify both high-level signals and low-level signals as well. And the difference between them, if the range is greater, then you can go lower on the low level, right? And now let's have a look at solid state technology. Solid state devices, transistors and chips, I don't know much about chips, but about transistors, they usually have that rail voltage of 35 volts, so they have 35 volts operating range. And tube amplifiers in general have between 350 to 1500 volts. So that's the range that generally most tube amps have, tube power amps. There are some which have lower than this, but there are some which have even higher. So I just gave what you can possibly run into in most cases. And we see that this range is, even in the worst situation, is we have a 10 times greater linear range compared to solid state devices. So it means that we have a 10 times greater ability to resolve small detail level. So if you have a 1 watt output solid state transistor, 1 watt output vacuum tube, then that vacuum tube has 10 times greater capacity to resolve lower detail levels than your solid state device. And here there people are saying, oh no, tube amps are noisy and stuff like that. That's the how you execute it. That's a different issue. That's not because of vacuum tube technology. That's because of excessive cost cuts. So for any kind of amplification, either tube, either solid state, you need to have very quiet power supply. And if you have equally quiet power supply for a solid state amp and a tube amp, now we are talking about business. But you cannot compare a solid state amp that has an exemplary power supply, and it's dead quiet compared to a tube amp that was maybe made in China. And for that I mean because usually people buy a lot of Chinese products because they offer an excellent value. So, and you can get a tube amp 10 times less the price than what you would expect a normal tube amp cost. And yes, you are getting 10 times lower performance as well, often. And it's because they are cutting costs left and right, and then you say, tubes are shit. And that's the reason for that, because if you cut the cost, then that's what you hear, cost cutting in your performance. But when the power supply is done correctly and you have a quiet supply for the amp, then the vacuum tubes have at least 10 times greater resolving power at the lower end than solid states do. So yep, so basically to resolve low level details you need super duper quiet power supply. Either you have transistors or tubes, doesn't matter. Power supply is the most important part to get the resolution. So if you have a solid state amp and you want to modify it to get more detail level out of it, go at the power supply. So for example, beef up your capacitance for the supply. If you can add another regulator stage or whatnot to make it quieter, do it. If you have a tube power supply and it's a CRC stages inside, change the resistors to chokes, add an extra stage and so on to make sure that your supply is quieter. And then that signal level that was covered by the background noise of your amplifier, now you can hear the low level signals in that region that was masked by the power supply noise. And when you have a tube amplifier, you are at an advantage because the lower you drop the noise floor, you can drop it lower and lower and you still get more amplification, more signal, more low level signal. And if for transistors you draw the noise floor to the same level, you will start to hear the noise of the transistors, and you are not getting more resolution, you are just getting more of that whatever, which is not noise but a different kind of random noise that the device generates. And try to lower your feedback, because the less feedback you employ, the less micro detail, the less transients are destroyed. And make sure that you use linear devices, because the more linear the device is, and the greater the linear range of the device, the greater the resolving power in the low region. For example, if you have a solid state amplifier, then try to increase the voltage, the power supply voltage. So if your transistor can handle it and your power supply can handle it, beef it up by a couple of volts at least, or more, as high as you can. And then your device, instead of actually that 35 volt scenario, it's a quite good scenario. There are lots of solid state amps which run on at 15 volts voltage. That's even much lower than that, way lower dynamic range and low level resolving power. So if you can increase it even just by a few volts, and you can do it without cooking your transistors, then you will reap tremendous benefits, provided your power supply is quiet enough. So I really hope that this helped everyone, and that's why when you look at Nelson Pass, and he has his first watt designs, that's why those amps are so good, because he's focusing on having one or just a few clear watts with a power supply that is bigger than what you would build for a 1 watt amplifier. So he puts in bigger supplies. Maybe I haven't opened up his amps, but I suspect that he puts in power supplies which would be good enough to feed a 50 or 100 watt amplifier or even bigger. And then you have all the juice, all the energy that you can release, but you do not overdo the amplification, so you do not introduce all that noise, all that distortion, all that extra feedback and corrections which just destroy low level signal. So do not dismiss low power amplifiers, whether tube or solid state. They can give you more micro details than a high power amp can do. You can be cheated a little bit if you are using low sensitivity speaker. Then a higher wattage amplifier can make the illusion to give you more lower detail level, because for a low sensitivity speaker the signal cone has to be moved with excessive force, and then the low power amp is at a disadvantage, even though it gives much more detail level, but it's lost because tremendous power is required to control the cone, and that low power amp doesn't have that damping factor, doesn't have that current driving ability to control that cone that finely. So when you have like a first watt amp, hook it up to a high sensitivity speaker where the cone doesn't need to, it doesn't feel like it's made of lead to the amp, but it's like a fast moving cone, so it can transmit and play all the micro detail level. So I hope you like this little bit of information, and just like and subscribe so others can learn. Thank you. Bye bye.